And welcome to my presentation. Let's do an exercise together before we start. I've noticed that the room is half full. Maybe people are just bored or I don't know, went out to eat. So just for the fun of it, let's make a lot of noise, clap as hard as you can. I first say, put up unit test, and you. Okay, how many of you write unit tests? Quite a bunch. For the rest of you, shame.
The rest of them are not in the room.
Yeah. Okay. So my presentation is about Jest. I found that for some developers, some of the pains of writing unit tests comes from the technical stack itself. It brings all sorts of hoops to jump through, a lot of configuration and all that noise just to get you started. So if you start out with all this bad experience, I don't blame that some developers are not open to writing unit tests. And hopefully after this presentation, I can give you a more clear look on why or how you can write unit tests in a more joyful way. Jest is a general testing framework. You can use it to test your JavaScript application, but it's a really nice fit when you want to test also your React applications. I write React, so some of the examples might be oriented in that direction, but the rest will be on generic JavaScript. Okay, about me. My name is Andrei Cacio. I write code at Mocha, and I also contribute to the Cluj-Napoca community. I invite you to come see what we do. It's pretty fun. Okay, so I'm gonna ask you, what do you use for unit testing? What tools? What? I don't know.
Jasmine.
Okay. Usually, not all stacks, but if you want to create a unit testing stack, you will need a few components like a test runner, assertion of framework or library. You're going to need a test coverage tooling to explore test coverages and so on. You're going to need a spine and stubbing way to do those things, and all sorts of stuff like that. One might use for a test runner, maybe you're familiar with Mocha. For assertions, you may use Chai. For test coverage, Istanbul. Sinon for stubbing and spying. And I couldn't find a logo for that. And Enzyme for testing React applications. This is not, it's a specialized tool, so don't concentrate too much on that. Okay. Okay, now the drawback for such an approach is that it's really, really painful to take it to that point where you're satisfied on how it runs, how you write tests, how easy it is to debug those tests, and you have to install all these plugins, all this configuration, and you have to make them work together, because they are tools that are built to work independently. So it can be a pain. So in my perspective, I think a better way is to have a stack that looks like this, right? One tool which has everything we need for simply running unit tests. So unit tests should be an easy thing to do, because they should be part of our applications, and they are a really important component in writing quality code. Okay, so like I said, Jest is a unit testing framework. It has basically everything we need. One more? That. So we have all this wonderful crap which help us write our unit tests, from test coverage, from assertions, from API, from simple APIs, and it also brings some other new features which I will take you through. Okay, so let's slowly break some of the most important stuff apart. Okay, so this setup. Technical difficulties. Okay. Thanks. Okay, so the setup. The setup, you might guess that it's really complicated. That's it. And I'm going to zoom in. In the back, can you read what's on the slide? Show of hands. No, you don't care? Okay. Okay. I'm going to zoom in. After you install Jest, you will have to only, if you're not familiar with package.json, to add commands. We have the scripts block where we can add a command for running tests. In our case, we simply add just CLI and everything works. Okay. Right out of the box, just comes with a really nice watch mode. I'm gonna demo it because it's easier. I'm gonna zoom in a bit here. Okay. I have here a really simple application, mostly for demoing. And like I showed you, we added that script there, and to run it, we simply call npm test. If we're gonna, by default, by running that command, all our tests will run, and we will get a pretty nice output. But I said something about the watch mode, so if we want to keep listening for how our tests are changing, we will pass a second argument called watch. Again, all our tests will run, and in this way we have some pretty cool features, which for me it really helped me out in being accessing really fast unit tests. I suck at this. You're going to take me out there. Okay, so we have here a few options for our watch mode. If you want to watch a specific file by its test file name, we have the B option. Let's say we want to watch only our spine test, the JavaScript test, unit test. We're gonna type in spine. It will do a search for that file, and we're gonna listen. We're gonna watch only for changes in that file. This kind of stuff usually comes in integrated with IDEs like WebStorm or stuff like that. But if you're into Sublime or more lightweight tools, you can get this right in your terminal. It's really fast. Also, if you wanna watch out for just one test, like this random number callback, you can hit T and let's say random. It will do a fuzzy search, and again, it will only listen to that test. If there were more tests, they would have been cut out and only listen for the random one. Okay. So this is watch mode. I invite you to explore the menu. It's really easy to use, and I, for one, found it really helpful. Okay. Like I said, Jest needs almost no configuration right after you install it. Because right off the bat, it knows how to look for test files. It has a few conventions, like file name endings. It will automatically, when you run Jest, it will automatically look for .spec.js and .test.js. If you have tests written with that file name, they will be run by Jest. Also, if you look at on the right side, Jest also supports having a test folder where you can isolate all your testing files, and they will also work. So yeah, you don't need much configuration. You just simply run Jest and it does all this. Okay, what about ES6 and writing unit tests using import, export, and all that? Jest plays really well with Babel. If you already have Babel on your project and you have a Babel RC file, you will only need the Babel Jest dependency and just will know to use your bubble binary from your project, and it will enable you to write ES6 in your unit test. So you can use import, export, and whatever bubble lets you do. The syntax, you may already be familiar with it. It's similar to Chai. We have the describe block. We have hooks before each, after each. We have the it, which is a specific unit test block, and the expect-like syntax, where we can check for certain values and so on. Okay, I shamefully copied this right out of Jest documentation, but let's skip that. Jest runs its test in parallel by default, so you'll see a boost in performance right away. I presented this talk at the Cluj JavaScripters meetup, and a guy there, Paul, he pointed out that in their experience, if you have multiple describes nested, more than 2 levels, Jest doesn't really know how to parallelize them well, and performance may suffer. But again, this only, it's a fine-tuning kind of thing, so it's nice to know. Okay, spying and stubbing. Are you familiar with these techniques? No? Okay. So what is a spy? A spy is basically a function, a dummy function, which we can send it out in our code, and then track whatever, how it was called, with what arguments, and all sorts of meta like that. You can think of it as a James Bond. You deploy in a mission and expect back some reports. What I really like about Jest is that it has the assertion. The assertion is built with spying and stubbing in mind. They coexist in a very harmonic way. If you use Xenon before, you would only test for Boolean values, like was this function called with these arguments, yes or no? But you wouldn't know the exact error if it was a no. Here we have the assertions which they blend really well with spying, because we can tell it explicitly. Was it called exactly 0 times? Or I'm going to show you the demo and you'll understand better. Okay, so let's say we have this function right here. It's a simple function which expects a callback, and it will call that callback with a string file. So nothing really special. So let's write a unit test for that. I'm gonna delete this because it's not what we want. Okay, who's gonna help me to write this unit test? Don't be shy. What we're gonna do?
First, import the function.
Yes, it's right here. Give me 5. But yeah, good catch. First, we need to import the function. I called it give me 5 so it'd be more readable. So first, we're gonna need that spy I was talking about. To create a spy in Jest, you simply call the Jest object, which is injected automatically in all the unit tests. You don't have to import anything. And you simply call fn. Fn returns a spy or a mock. And then we will call that function with our spy. Basically what we are doing, we're sending in James Bond, and he'll come back and report to us what happened to him. Okay, and then we can do expect spy to have been called with 5. Okay, so let me just zoom out a bit. Okay, so if we were going to run those tests, we will see that they will pass, hopefully. Yeah. So the random number callback checks out. So what I was trying to say about that nice blend between assertions and spies is that if we make the test fail, let's say we pass in 10, not only will get that some test failed, we will also get a pretty good explanation on what happened, what are the differences, what arguments were expected, and so on. As far as I know, you can only achieve this kind of readable output with Xenon if you install all sorts of plugins and all that. It's doable, but again, it can be a pain. So yeah, we have this nice diffing, and it's I found it really helpful. Okay. But if you want to check for specific arguments, we can always access the mock object, which we have on all spies, and we have a calls two-dimensional array, which we can access each call. So if it was called 5 times, you can get that third call and that nth argument. Like in our case, we have the first call and the first argument, second argument, sorry. And we can check for arguments in particular. Okay. Okay, so we have stubbing as well. So what stubbing basically is, it's a technique of listening or transforming a function on a given object, and we want to track how that function is called. We can think of it of a spy attached to an object. We can either simply listen to how it's called and how it moves around in our project, or we can take out the implementation altogether and give it a custom implementation, like in the second example. We can use mock implementation and give it a function to do whatever we want. Okay. So asynchronous tests. Okay, so let's say we have a function. Let's say we have a simple function that returns a promise. If you want to test that in basically almost all tooling, you have this classic pattern. We have to return that function, call it, and then access the result on the then callback. And then we can assert that value to be something or to equal something. However, in Jest, because it has that Babel implementation, which works really well, if you have asynchronous tests enabled via Babel, Jest will also play along well. We can refactor our test to use async await to minimize the code and write our tests in a more simpler way. To achieve this, we have to add the async keyword near our function in the it block, and we'll simply await on the expect. And like I said, Jest has this, the assertions in Jest, I'm gonna probably repeat myself, are really nicely baked in with the common patterns we use in JavaScript. So for promises, we have a specialized assertion. We can call results to unwrap whatever we will get on that promise, and we can check it to be a value or whatever we need. Okay, so snapshot testing. This is a really interesting technique that Jest brought to the table. I don't know if other tooling gives this kind of way of testing, but let's explore it. Okay, so let's presume you have a simple React component. Okay, but first let me explain what snapshot testing is. If we look in the Jest documentation, snapshot testing is basically a way of knowing if your UI changed. To achieve this, we will see in a few seconds. how we can achieve this. Okay, so let's say we have a simple button component. It expects a label, and it will return a button tag with that label in it. You can test this using other toolings like Enzyme. You can check for that button, you can check for that label if it exists, and so on. But with snapshot testing, things get interesting. So let's see how our test will look like for this case. Okay, so how snapshot testing actually works, it's you basically render that component using a renderer or this serializer. In our case, I've used React's renderer, which is an experimental renderer, which will help me to render my component in isolation. Okay, then I want to transform that component into a more readable format, like JSON. So this renderer right here offers me the to_JSON method, which helps me to export my component in a JSON format. And finally, we have this specialized assertion function called toMatchSnapshot, which will do two things. And I will show you in a few moments. So, you probably want to see how that snapshot really actually looks like. It's literally a file on a disk. You pretty much dump your component in a file, and you keep snapshots of that component in a file, and then Jest will do diffings on them. So if that component changed in any way, Jest will say, hey, it has a new class name, or something's missing, or etc. Let me show you exactly what I mean. I'm going to delete this, and I will tell you why in a moment. Okay. So we have that component I showed you here. It's exactly the same component, and we have the exact same test. This. You didn't see it. Okay. And we're gonna run Jest and see what happens. Let me fix that test I broke earlier. The joys of unit tests. I hope I didn't mess up the demo again. Let me rerun that. Okay. And we should see a new message in our let me delete this again. Again, take 2. And hopefully, yes, we will see this message. Like I said, when you run Jest, it will do two things when it will encounter that to_matchSnapshot assertion. First, it will dump that file on the disk. It will create a file, create a JSON, write it, and be done with it. So it doesn't check for anything. It will always pass. And we will also get this message saying that, yeah, we've written 1, 2, 4 snapshots. The second time we will run Jest, it will actually look for differences. It passes, but let's make it fair. If we go quickly here and by some reason make this spam, if we run Jest again, it will have to notify us that, hey, your component doesn't render as it used to do. We get this really nice Git-like diffing where we can see exactly what changed, what was expected, anywhere. Right now we have basically two options. We can either revert the change, which broke our test, or we can update the snapshot. Updating the snapshot is as easy as pressing a button. We can either do run Jest with the U argument, and it will notify us that one snapshot was updated and all is fine. Okay, so what I want to take away from this is that Snapshot testing can be a good way to test your React components or large data sets, like if you want to test really big objects or JSONs or stuff like that. Stuff that usually it has a complex structure. But I don't recommend using this as a go-to thing for any component, because it can be really painful if you tend to abuse it. Because as snapshots get bigger and bigger or more complex, nobody will have the patience to actually track down that if that change, especially if it's UI stuff. We all know UI can get really big. And if you're going to see that, hey, a new class name was added, oh, screw it, outdated, I don't care. And that's why I'm saying the big cons of this approach is that it can get really messy. And for me, I've been there, and on one project we had really ugly snapshots, which nobody wanted to maintain anymore. So yeah, I guess use this with caution, and if it makes sense for you, I invite you to use it. Other developers prefer leaving the components to the QA team to do end-to-end tests. But if you're short on staff and you want to test your code, maybe this is a good fit for you. Okay, I'm really excited about this feature. First, I want to ask you: are you familiar with proxy acquire? You heard of it? No? Yeah. Okay, so proxy acquire basically lets you mock out modules, right? We are using, say, we have a Node.js application and we want to mock out some dependencies. The proxy acquire API is usually also, the proxy acquire also is used in some unit testing stacks, but I found it really a bit painful and the API a bit complex, so kind of beats the purpose again. So with Jest, we have this module mocking ability built in. So if you want to mock out a module, say we want to test a module, right, which depends on another module. We are not interested in what this module does, so we want to take it out. We're going to simply say, hey, just mock this module and give it a custom, say, export me 2 functions which do nothing and let me be. This is how we can mock out with Jest. We have jest.mock on the global object. The first argument is the module path, and the second argument is the custom export we want to give. Okay? Or, even an even better way, you don't want to, probably if you want to test modules which depend on pretty common other modules like utilities, you don't want to copy-paste that interface all over the unit test, because you want to keep things dry and it's pretty much stupid. So Jest has another cool thing built in. If you want to write that interface once and use it everywhere, you can create a dash folder if you look on the right side. It has to be a sibling to the module you want to mock out. In our case, utilities, right? So basically, we create a mocks folder right near our module, and inside, we will add the same file name, in our case, utilities, and there we will export whatever we want instead of the real deal. So if we have 2 functioning utilities, we're going to export those, but with eyes or whatever. The beauty of this is that in your unit test, you will always have to say, hey, just mock out utilities. With what? I'll take care of it. It goes to mocks, grabs it, and you're done with it. So it's really, after you write all your interfaces and all the stuff works together, you'll find that unit tests are much easier to write. So yeah, pretty exciting times. This approach goes really well with another nice Jest utility. You don't want to maybe you don't want to write those interfaces by hand, right? You want to somehow generate them automatically. Just as a function called generate mocks from file, where basically you give it a file name and it will automatically mock out its exports. Let me do a quick demo here. If I have time, or maybe I don't have time. I will not do the demo. Maybe if I have time at the end. Okay, so it has built-in coverage. It's not much to do than, again, add a special script with the Jest command line and the coverage argument. And if we will do that in our project and run npm run coverage, we will get a nice coverage report on our unit tests. And moreover, it will create this coverage folder right here. And if we go inside, I don't know if you're